Hey guys, so today I'm going to talk about the several more important rules of differentiation in calculus. So the rules I'm going to introduce today are firstly the product rule of differentiation. So the product rule is a very important rule. It helps you to differentiate a function that's the product of two other functions. So for example, so we have this function which is equal to g of x times f of x. So this is equal to the derivative of this is equal to the derivative of gx. G prime x is used to denote the differential, times fx. So this thing times the derivative of fx times just the normal gx. So let's put this into action. So for example, we know, so of course the premise of this rule is that gx and fx, the derivatives of gx and fx both exist. Now this tests the product rule with an example. The derivative of sine x times cosine x. Now by the product rule, this is equal to sine x multiplied by negative sine x times, so this thing times, now we're going to differentiate sine x, cosine x times cosine x. Now as you can see, there are some pretty obvious simplifications here. This is equal to negative sine squared x. This is equal to cosine squared x. So now this is the finalized derivative. So now the product rule is simple enough. It's also very easy to remember. So now, beyond the product rule, we have the quotient rule. So we have two functions again. So we have a function that is a quotient of two functions, fx and gx. And this is equal to, the derivative of this function is simply equal to the derivative of fx, and of course the premise is that fx and gx are both differentiable, times gx minus gx times fx. And this is all divided by gx squared. So now let's see this into action. Let's suppose we want to differentiate x squared divided by 2x. This would be equal to, first we differentiate fx, 2x times x squared minus, what's the derivative of gx? 2 times fx. So this is equal to 4x divided by 4x squared, because 2x squared is 4x squared. So now to simplify this would be equal to 2x to the third power minus 4x divided by 4x to the second power. Now this is our derivative. And it's quite simple. So now the quotient rule, the product rule, what comes next? Now the next rule is a way to differentiate composite functions. And what are composite functions? So composite functions are a function that f g of x, which would mean composite functions. The x for a composite function is another function. For example, constant functions include sine x squared, cosine 2x divided by 3x to the fourth power, dot dot dot. But I'm pretty sure you get the idea. So the input is, so instead of an x for the input of the function's variable, the input for the function's variable is another function. So now, how do you differentiate these functions? So and this rule is called the chain rule. So the derivative of a constant function is equal to f prime of g of x, which would mean we ignore whatever's inside this function. We just have the f function, differentiate the f function, and put the gx inside of it, and we multiply this by the derivative of g of x. And now, so this is very simple. Let me provide an example. So let's say we had we want to do differentiate cosine of sine of x. This would seem very complicated, but by the chain rule, this is simply equal to negative sine of x multiplied by negative sine of x. So now this is very simple. You take the derivative of this thing, put it on the right. Oops, sorry. This isn't negative sine of x, this is cosine of x. Let me erase this portion. This is simply cosine of x. So now, let me give you a visual representation. You take this thing, take the derivative of this thing on the insides, put it on this side so that it becomes negative cosine of x. Take this thing, the whole portion, take the derivative of that, put it on the right side, and multiply it by this thing. So the derivative of this thing would be equal to sine of a sine, negative sine of sine of x, and multiply it with this thing. So now this is all very simple. Let's do some practice problems that sometimes you might find it necessary to use the chain rule more than once. So because the result still might be a composite function, and it still might be the derivative of a composite function, and you would need to use the chain rule once more. So this is one of the times. So remember when I said that differentiation was easier than integration? Well, those questions can prove this, because if you wanted to take the integral of this, well, it's very, very difficult. I'm not even sure if there is an integral of this, but the differential of this really exists. So now we only have to use the chain rule. No complex calculations have to occur. So this is our first example. It's a trig function example, and it's three trig functions nested inside of each other. So this would equal to secant squared. Remember the derivative of tangent of anything secant squared. Secant squared of cosine of sine of x multiplied by the derivative of cosine of sine of x. So this would equal to, we keep this side the same because it's finalized, and we need to apply the chain rule again. So this would equal to negative sine of x multiplied by cosine of x. Now, so this is the finalized result. Let me shrink it a little bit so you can see it in its entirety. So it's not bad. It's very lengthy, but that's okay. We applied the chain rule twice, and the first time we took the derivative of tangent x and put it as secant squared x. We left that side unchanged and took the derivative of this side. And so that question was very easy, but I find but nearly every question with differentials are much easier than integrals. So the next question. What if we wanted to differentiate? Oops, my handwriting is a little messed up. That's because it's very difficult to write on a virtual whiteboard. Sine, I don't know, to the third power of x. Now, you might not see this at first glance, but sine up to the third power of x is simply equal to sine to the second power of x times sine of x. Now we can actually apply the product rule. So this would equal to the derivative of sine squared of x times cosine of x plus sorry, this part's not cosine of x, it's sine of x. Don't take the derivative of sine of x. So you add cosine of x plus, this is multiply, not plus, my apologies. So we have this thing. So what is this thing going to equal? So what's sine squared of x? It equals sine x multiplied by sine x. So this will be equal to, we use the product rule again, cosine of x times sine of x squared plus cosine of x times sine squared of x. Now this is a finalized derivative. So I am about finished with